Hi, my name is Diogo and I'm going to talk about our graph mining project. In this project, we use the dataset containing votes from the Brazilian Congress's deputies in the last 20 years in order to analyze the political scenario based on the relationships among politicians and parties. The Brazilian Congress currently has 512 deputies and 81 senators from every state. They are divided among 21 parties and are responsible for voting on bills, constitutional amendments, and other legislative affairs. We collected all individual deputy votes since 1995, which are publicly available and contain information about each bill and deputy. We would like to understand how the relationships evolve through time, both between parties and inside a single party. In order to do so, for each year, we built a graph based on the similarity between deputies. We then applied clustering and pattern mining techniques in order to try and find interesting relationships using the graphs. The picture shows, for each year, the proportion of each type of vote a deputy can give. It is possible to see that proportions vary through time. For instance, it is possible to see that, at least for the last 12 years, the proportion of yes votes is higher during election years. We can also observe that the vast majority of votes are either yes or no. Based on this fact, in our analysis, we calculated the similarity score for each pair of deputies. The score is based on the agreement, or the lack of it, between the two politicians' votes. This picture shows that most votings are dominated by a single type of vote, either yes or no. For instance, in 50% of the votings, a single type of vote accounts for more than 70% of all votes. Due to that, votings cannot be considered equally when calculating the similarity score between two given deputies. These figures show, for each year, the accumulated distribution of the proportion of deputy absences. We can see that absence in votings is not uncommon. For instance, approximately 50% of deputies are absent in more than 30% of the votings. Because of this, in our analysis, we consider only deputies who are present in at least 50% of the votings. The figure shows the accumulated distribution of the proportion of deputy presence per voting session. We can see, for instance, that 10% of the votings have up to only 50% of the deputies present. This shows that, although there are many absences in general, they are concentrated in a small set of voting sessions. We calculate a score R for each voting session and pair of deputies. This score is a function of the deputies' votes and the majority vote in the session, which accounts for the fact that some votings are less representative than others. The similarity between two deputies is then the mean score for all voting sessions in which both were present. These figures show the distribution of similarity between pairs of deputies. Two behaviors can be observed. The first is a bimodal distribution, which we consider as a mixture of two distributions, one related to the similar deputies and another related to the dissimilar deputies. The second behavior is a unimodal distribution, where the distinction between both groups is less evident. For each year, we defined a cut point to indicate which deputies are similar and which are dissimilar. In the case of bimodal distributions, the cut point was the minimum value between the two peaks. For unimodal distributions, it was the peak value. We then shifted the distribution so that the cut point equals 0 for all years. We used the Markov cluster algorithm to perform the clustering of deputies. Since the algorithm uses edge weights as transition probabilities, we considered only the non-negative edges of each similarity graph. Experiments showed no impact of the inflation factor on the quality of clustering. However, a high inflation factor led to more clusters. For the clusters in the figures, The inflation factor was set to 2 in order to minimize the number of clusters and allow for a comparison of supporting and opposing parties. For the sake of visualization, deputies in the same cluster were grouped according to their parties. The size of each party node in the images is proportional to the number of deputies from that party in the cluster. Colors and labels identify each party, but please note that they are different in each graph. These particular images show the transition between the mandates of Fernando Henrique Cardoso from PSDB and Lula from PT. As an example of interesting observations, we can see that some parties, such as PMDB and PTB, shifted from supporting PSDB to supporting PT, the new presidential party. These figures show the first and last year of the first mandate of President Dilma Rousseff. We can see that, in 2011, the government supporting base was grouped into a single cluster, pointing to a higher cohesion among deputies in the group. On the other hand, in 2014, the official government supporting base was split into two different clusters. One contains PT, and the other one PMDB, reflecting the recent frictions between the two parties. For all graphs, the clustering of deputies showed that the political parties are coherent, since the majority of deputies of each party belong to the same cluster. In an effort to compare clusters generated within each presidential mandate, we mapped each cluster to a point in a p-dimensional space, where p is the number of parties and the value of each coordinate is the number of deputies from the corresponding party. We then applied a principal component analysis to reduce dimensionality and provide a bidimensional visualization, which allowed for easier interpretation. We can see that, in general, the clusters remain similar within a given mandate, indicating a relative stability in the political relationships. For all presidential mandates but the last, the first two principal components accounted for at least 93% of the variance in the data. For the last one, they accounted for 80%, probably due to cluster dispersion. In the second part of our analysis, we wanted to identify persistent relationships between political parties throughout each presidential mandate. We defined a persistent relationship as one which occurs during all years of a given mandate. Since clustering is not appropriate in the light of this restriction, we employed a frequent pattern mining algorithm. In our approach, we built a party similarity graph from our deputy similarity graph. Each node in the new graph corresponds to a party. At first, the edge weight between two parties was calculated as the average of the similarity between all pairs of deputies from those parties. Then, we defined two edge labels, one for edges with positive weight and another for negative ones. The algorithm we used performs the uniform sampling of frequent subgraphs and employs a Metropolis Hastings framework to sample frequent subgraphs from the output space. Support was set to the number of years in a presidential mandate, and we selected the largest frequent subgraph sampled by the algorithm. These figures show frequent subgraphs found for each mandate of President Fernando Henrique Cardoso. Blue edges correspond to positive similarity between incident parties, while red edges correspond to dissimilarity. This allows us to see that parties from the government support and opposition groups not only agree among themselves, but are indeed contrary to one another. In contrast to the clustering approach, here we have both positive and negative edges. As a consequence, we are now able to identify interesting situations. For instance, in the first image, we can see that PRONA is positively related to PSDB, but although PSDB is also positively related to PFL, PRONA is not. Also, PSDB is contrary to most parties from the government supporting base, while PRONA is contrary to only two. Finally, in the figure on the right, we can see that PSOL is also contrary to the government supporting base, but is not allied to the major opposing parties. In hindsight, the results reflect Brazil's political history in the last 20 years. Clustering the deputies allowed us to verify intra-party cohesion and observe Congress partitioning on a yearly basis. Frequent pattern mining allowed for a deeper analysis of persistent inter-party relationships throughout presidential mandates. Finally, both methods yielded interesting observations and were able to identify at least two relevant groups of parties, those which support the government and those in the opposition.